Well, that's the problem. The James Webb Space Telescope is upsetting the apple cart.
Since its launch in July 2022, the James Webb Space Telescope has made stunning discoveries, challenging our understanding of the universe. It's now encountering a structure that, according to previous theories, should not exist, casting doubt on the entire Big Bang theory. This discovery has sent ripples of excitement across the scientific community and compelled scientists to reevaluate their theories. What was in the beginning? To comprehend the early universe, we must go to the point where time and space, as we know them today, did not even exist. According to the Big Bang theory, all potential remained in a state of perfect equilibrium, resembling a great nothing with our current measuring methods. With a minimal shift, the universe arose from a single starting point, unimaginably tiny, smaller than anything visible to the naked eye, yet representing all points that will ever exist. The Big Bang initiated cosmic inflation instantly, causing the entire universe to rapidly expand from subatomic size to that of a golf ball. Whether space came into being only then or existed before is unknown. The very first phase of inflation corresponded to a 90-fold multiplication within a fraction of a second. The cosmos grew from the subatomic to golf ball size at the moment of the Big Bang, and the expansion continued until today. The universe cooled down slightly, but for 400,000 years, it was too hot for matter or light to form, according to previous calculations. The era of light formation allegedly lasted over 500 million years. Initial stars formed, shining individually or creating wild, disordered star clusters in the early universe. Galaxy structures with a high order in a spiral or disk form were thought to emerge after about 1 billion years or later. However, the James Webb Space Telescope has identified at least 6 galaxies fully formed only 500 million years after the Big Bang, posing the scientific challenge. A team from the University of Minnesota found a tiny galaxy that generated an unusually large number of new stars for its size. Despite being only about 1/millionth the volume of the Milky Way, it formed a comparable number of stars annually during the time its light reached us. The other 5 galaxies exhibited unexpected features, offering a different view of the early cosmos. Studying these early galaxies will help scientists understand more about the formation of the first stars and galaxies after the dark era of the universe. Currently, there is a growing question about the time period just over 13 billion years ago and whether it truly marks the cosmos' beginnings. This prompts a reconsideration of the universe's age, thanks to the James Webb Space Telescope. Upon the launch of the James Webb Space Telescope, scientists worldwide anticipated new insights into the cosmos due to its unique technological capabilities. NASA, the Canadian Space Agency, and the European ESA invested around $10 billion for this purpose. After more than 20 years of exploration by the Hubble telescope, the JWST aimed to delve even further into space, with a range extending to at least 13.5 billion years. While not significantly expanding the scope compared to Hubble, Webb's sharper view enhances measurement results in analyses. Researchers can now study objects billions of light years away by observing minimal shifts in their light emissions or redshifts. The sharper image improves measurement precision. Astronomers, leveraging the new telescope, seek to gain insights into stars and galaxies shortly after the universe's formation, a primary goal of the JWST mission. Scientists using the James Webb Telescope have made another sensational find. They discovered a structure that could be the oldest known black hole in the universe. Thanks to the telescope's ultra-high power sensors, structures revealing the presence of a black hole have been detected for the first time, approximately 570 million years after the previously thought Big Bang. Black holes are remnants of old dead stars. This intriguing structure is also a supermassive black hole, suggesting that several black holes may have collided and merged into one. Another possibility is the explosion of a very large and massive star. If these events occurred 570 million years after the Big Bang, it implies that the stars forming the black hole at the end of their life must have been much older. Astronomers already know that the first stars probably had relatively short lifetimes, with blue supergiants possibly burning out after only a few 100,000 or million years. However, this doesn't explain the existence of such a large black hole shortly after the Big Bang. The discovery of 6 galaxies, highly structured and rich in stars at the alleged beginning of time, adds another layer to this cosmic puzzle. To form galaxies, time is essential. Our own galaxy likely started as a mere collection of stars. Clusters formed, stars exploded into black holes, and these collided, growing into larger ones. Gigantic black holes began pulling more stars into their vicinity. Their gravity-shaped surrounding structures into disk or spiral forms, giving rise to galaxies. This process spans billions of years. How cosmic black holes grew so large quickly, and how galaxies existed 200 to 300 million years post-Big Bang puzzles scientists. CEERS 1019 was found in Hubble data during a search for the oldest light traces of star formation. This first light, called Lyman alpha emission, results from the ionization of neutral hydrogen. Previous assumptions suggested the early universe was filled with neutral hydrogen, hindering light spread. Only after ionization could light flow freely. The reionization process remains a scientific mystery, possibly never occurring. All theories and cosmic models have been on the test stand since Betelgeuse. Possibly, everything researchers assume so far is wrong. JWST, an extremely powerful infrared instrument, took a much closer look at CEERS 1019 and its supermassive black hole in this ancient galaxy than Hubble. Once again, researchers were in for a surprise. Galaxies of this age usually emit light only from early star formation. However, this galaxy showed traces of light from both star formation and a black hole. The black hole itself doesn't emit light, but it gathers matter around it in a unique way, causing the matter to glow. CEERS 1019 exhibited both types of light emission, a circumstance considered unrealistic. Now, researchers are faced with more riddles and mysteries than ever before. These discoveries mean that decades of work in various branches of astronomy and cosmology may need reevaluation, leading to recalculated theses and rewritten textbooks. Imagine you've just left school, your degree in your pocket, and you're rejoicing. Then someone comes along and tells you that everything you learned about physics, mathematics, and chemistry was a mistake. That's exactly how researchers around the world have felt since the JWST began sending fascinating but perplexing data to Earth. Meanwhile, the strange discoveries are not stopping and only continuing. More unusually large black holes have been found in the early universe. Among them is J1342 plus 928, discovered 690 million years after the Big Bang, and containing a supermassive black hole. The center of this early quasar galaxy is 800 million suns in size. Another black hole was found in the galaxy J0313 1806. This one already existed 670 million years after the Big Bang and has a supermassive black hole, which is 1.6 billion times bigger than the Sun. Is the Big Bang disproved with it? For many astronomers and space fans, after these stunning discoveries, it's already certain that the Big Bang theory has been disproven. But the world of science still resists so far such statements. For almost 100 years, the theory of the Big Bang appeared to be coherent, and many other observations, such as the expansion of the universe and data from cosmic background radiation, seem to confirm such assumptions. Researchers are not quite ready to abandon the Big Bang. After all, it would be conceivable that the birth of the universe simply happened much longer ago. Perhaps our cosmos is 15 or even 20 billion years old. Just as well, it can be that the universe behaved completely differently in the beginning and has been assumed so far. It could have cooled down faster. There were stars, galaxies, and black holes much earlier. Currently, teams of scientists around the world are working to reconcile the new findings with the old theories. Whether this will be possible or whether the tExist will finally do away with the theory of the Big Bang, we will know in a few months or possibly in the next few years. Scientists are grappling with unexpected revelations, questioning the long-standing Big Bang theory. The cosmos' fundamental nature remains a captivating puzzle. For now, scrutiny surrounds the theory, but researchers are resilient in their pursuit of understanding. They explore the possibility of a much older universe, or one with different early dynamics. Teams worldwide work diligently to reconcile new astronomical observations with established theories. Whether they find a connection or the tExist reshapes our cosmic narrative, the upcoming months or years hold promise for deep insights into the origins and evolution of our universe. Now please tell us your thoughts on the Big Bang theory. Considering these new facts, is the theory still plausible for you? Let us know in the comments below and subscribe for more content.